Okay. Can you hear me, Sarah?
Yeah, I can hear you.
Oh, okay, good. And also, can you see the screen I just shared?
Yeah, I can see the screen.
Okay, thank you. Okay, here's the time. Let's start. So today is Lab 4, and please go to Canvas and then download everything. We only have one HTML file for today. Yeah, just instruction. We have no any required data. Just let me just clear. Can you guys go to modules and then check if this link works? Yeah, because last time we did didn't work. I just want to check. Okay. So before we start Lab 4, is there any questions about last or anything about lab or class? Okay. All right, so for today, we're going to make a fire spread model with only patches. So we're not going to use any totals or link. We'll use a patch. This is more like cellular tomato. So each patch has their own attributes, and then we're going to use the attribute to make a fire spread. Okay. So here, the basis of this model is that the fire is diffusive process, the spread between a burning cell or non-burning cell. So each cell has their own attribute named vegetation, which is green color. We're going to color it green. And if the green color patches are around the burnt cell, then you're going to spread. If not, then you're not going to spread and stop. Okay. So please open the net logo and also HTML5 to start. And also, for those who use the CSPC, VMware, we just ask the CSPS team to reinstall the net logo in VMware, so you can also use the net logo in VMware. All right, please open the net logo and then go to code. Then go to code and then globals. So we always make a global variable first, right? So here, okay, I'm gonna just modify a little bit. So we're gonna make a variable named density. So this density we're gonna play a really significant role to make initial vegetation. Okay, so if the density is really large, then the number of vegetation will be the larger. So here I can just copy, make a global variable density, and then also make patches on attributes named burning and question mark to make a Boolean variable. Good. Okay, and then let's make a red line here to just to separate, make the other function separate. So here we're gonna make the setup and end. Now we always put the two basic command to CA, which is clear all, and reset ticks to initialize tick to 0. Right. You can check here in here, right? And then set density to 50. And set up like this. Okay, so now the densities will be initialized to 50 if we start, if we click the setup button, right? So, and then we're gonna ask patches like this. So we're gonna ask patches to do something and ask if random float that ranges from 0 to 100 is lower than density. Density is now 50, right? So it's like 50% chances. At 50% chances, we are gonna set this patch, this patch's color to green, right? So it makes all the patches, the 50% of patches were green, right? Okay. In set a function like this way. Yeah, in between set density. Of course, this function should, it should be put after this command, right? Because we initialize density first. Okay, and then check if there is a error I don't have. Then go to interface. Oh, yeah, go to interface. Where is it? Okay, just yeah, stay in the code. We're gonna make one more statement. So here, we're gonna add one more code like this. So we're gonna ask patches with px coordinates to 0 and px coordinates 0. So it means that if this patch is at 0, 0, it means that we choose only one patch that's at 0, 0, right? And then we're gonna ask these patches to ignite, right? And we didn't define yet what ignite is, right? So only patch at 0, 0, we're gonna be ignited, right? Okay, and then put this after the code of this code. So after we initialize all the patches, with the green colors, and then we ignite one patch. And then we need to define what function is, right? So this is additional function other than setup or go. So I'm gonna make another break line here, and then put this here. Yeah. So this function, this init function, we're gonna set p color to red. So it means that the patches at 0, 0, we're gonna be red, right? Not green or black. And then set burning to true. So that patches were gonna be red, and also at the same time, the attributes of named burning will gonna be changed to true, right? From false. Okay. And then let's go to interface, and then we're gonna make a button. So let's go to just check the button here. We push the button and name as setup to link this interface to the code, right? Okay, and then you click OK, and push the setup to make all the patches 50, green at 50% chances, and also the red color in the middle here, the center. Okay, is that working? Good. Good. Okay. So we're gonna make model fire. They will be spread out through these green vegetations. Okay, so yeah, for the diffusion. Okay, so we're gonna make now. We're gonna make a go function to model the fire spread. Okay, so click, just block in Okay, I just put the go function below the setup function. Okay. Cool. And then we're gonna ask patches to ignite. I mean, we're gonna choose one of the neighbor of that patches that's now won't catch on fire, and then we choose one of the neighbors, and then if the neighbor is green color, then we're gonna make fire spread to that direction, right? So copy this code. I'm gonna put this here before tick. Ready. So it means that let's see the code. So we're gonna ask patches with P color red. It means that at first stage, at first tick, we chose only one patch at 0,0 because that patch at 0,0 is only the patch that has red color, right? And we choose it. And then we choose neighbors. And then we use neighbor four functions to choose one of the four, neighbors following the loop neighbors, right? Based on the loop neighbors. And then choose one of them. And if the one of them is green color, then we're gonna make it ignite. Right? We're gonna change that to red color, which is burnt. Okay. Good. And after that, after first tick, if and then we reach the second tick, then there should be maybe one or two or three patches that are burnt, right? That are burnt, and then those are inside. Those will be inside this conditional statement later, and then we're gonna check if the neighbors are green, and then spray again, right? So, yeah. Okay. Let's go back, and then let's make a go button if there's no error. And then I'd rather to make a check. I'd rather check the whatever button. Make to to run this simulation constantly. And then click OK. Good. And then set up again. And if you put the go button, then the fire will spread out like this, right? If the vegetation does exist, your neighbor, then you're gonna spray it like this way. Okay. Any questions about it? Good. Okay, so now we have a density as a global variable in code section where the density, but we're gonna define the density in the interface with what is it? With slider, okay, so that we can adjust the density, in the interface. So let's make the slider, and then write the density in the global variable compartment here. And the maximum is 100, right? And then default value, maybe you can put just 70 or anything. And then if you click OK, then of course you need this software will move you to here. You need to make the density comment or just delete density, because you already define what density is in interface. You don't have to declare it again in code section. So you can just delete the density or make a comment, And also you need to delete this command too, right? Because we now we don't have to define the density amount anymore, right? So just delete those two codes here, and then check if there's an error. If there's no error, then just go back into interface. Then just that's it and check if it works. So if it's 70, you can see more vegetation here. If it's 100, then there should be like all vegetable. Good. Okay, and then yeah. After that, we're gonna rescale it. As everything works fine. Okay. Okay. So now we're gonna rescale the landscape, which is word. So let's go back to the logo, and then click the word, and like right button click and then edit. Now I'm gonna make it 100 by 100 and uncheck the word wraps. Yeah, to make it envelop space. Okay. And patch size to maybe 2 or 2.5. Just try not to make it too big. And then click apply, and then yeah, okay, I think it's good. Or I can make it bigger. Okay. Sure. Okay. And then check and then hit the setup button to check if you rescale the word. Everything good? Okay. And then put this code to stop the simulation at 100 ticks. So you need to put this, you need to copy this, and then place in the go function right here. The last this will be the last code in go function. Good. All right, and then go to interface and then check if the fire spread going well, right? And then it stops at 100 ticks. Right. Good. So any questions so far? No? Nice. And any questions about the process, or why it happened, or what the code function says? Yeah.
Is there any way that can be like vegetation more not randomly reduced?
Oh, of course it is. So you remember the last time we used the digital vision. So of course you could make it one by one, which is I'm not recommending. But you can use it as Excel and CSV file to make it. Yeah, so you can just refer to the last lab, and then do it. Yeah. Right. So any possible, any you can you can refer to Lab4. Yeah, sure. Okay, good. All right, and then we're gonna include the stochasticity. So to ignite or extinguish fire, right? Like naturally, right? So with some certain like probability, the fire we're gonna be spread or we're gonna be extinguished, like naturally by the chance. So let's put. I mean, first we're gonna make a stochastic model of fire extinction. Okay. So let's make extinguish function. Okay. So you need to put this code in Go function, of course, here. So every time the simulation goes by 1 tick, those coder will gonna be operated, right? So either ignite or extinguish. Right. And then yet of course we didn't yet decide or make extinguish function yet, right? So there should be error. Now we're gonna put extinguish function. So the last lines like this way. Yeah. So please put the extinguish function here, the last line. So yeah, just maybe 1 minute. So now we have two functions, two additional functions, other than the setup or goal function, right? Ignite and extinguish. So the extinguish function here now, the fire we're gonna be extinguished by certain probability here, right? So we're gonna make random flood that ranges from 0 to 1, right? And if those random flood is smaller than extinction, which we didn't decide yet, then the peak color becomes 12. It means that the 12 means dark color, dark red or brown, dark brown. And then the burning attributes were going to be false again, right? From true. And then we need to set the extinction, right? So extinction should range from 0 to 1, right? So you can either put extinction variable to the global variable input or interface, right? So I'm going to put the interface in as a slider. So just put a slider here and then name global variable. What's that? Extinction, yeah. And then increment to 0.05. The maximum should be 1 set. And then default value as 0. Maybe 75. Right. So it means that at 75% chances the fire are going to be extinguished naturally. Stopping spreading. Okay. So and then click OK. So if you put extinction maybe to 0.15, then the fire will not going to be spread out to like strongly. But if it is like a 1, then oh yeah, it's certainly extinction. Okay. Oh. Just wait. Just give me a second. Okay. That's very weird. Oh yeah, it's not weird. Okay, I just confused. So yeah, so yeah, I just think it like opposite way. So yeah, the extinction is like the probability of extinguished, right? So the more number you put, the higher the probability the fire is extinguished. Okay, just yeah. Yeah. So if you put like 85, then like it's highly likely to be extinguished naturally. Okay, good. So and then we're gonna put like stochasticity also into the ignition function. So let's yeah, let's put this code in to the goal procedure as well. So we need to like actually modify that a little bit. So let's see. So we have ignition. No. Okay, so instead of here in instruction, so instruction said you need to set ignition like this way, right? But we're gonna make a slider instead of this. So let's make a slider named ignition here. Maximum will be 0 and increment will be 0.05. It's the same. And then the default value will be 0.75. You click OK. Very good. All right, and then we're gonna add this code. So here, if you see the the way to ignite the catch is like this way, but here, I mean it's a setup. So here, yeah, here. So we need to change the code. So here, it's just like if you see this, so just ask one of the four neighbors, and if the one of the four neighbors is green color, then we change it to ignite, right? We change this statement to ignite. But now we're gonna ask one of the neighbors, and then we're gonna put this function to put the stochasticity, right, for ignition. So just you need to change code here, like this way. So now we ask one of the four neighbors, and then if it's green, then we ask again, right? If the random flow is lower than ignition, then we're gonna split or not at this chances. So let's go to interface. If there's no error, and then just adjust extinction ignition to check if it works. Okay. Answer might work well. Okay, yeah, so let's go to the next step. So now we're gonna measure fire spread. So how many patches are burnt? So yeah, let's set up. Okay, so let's make a two. Oh yeah. Oh. Oh, yeah, so you need to look into it. You need to put this inside of this pan. Yeah, so I don't do it. It's the same color. So this has should be inside. So then yeah, I'm gonna show you. Yeah. Oh, is this setup? No. So this is setup, right? Okay. Yeah. Well, yeah. Yeah. Is there any questions in Zoom? People in the Zoom? So yeah, I'll go to the next step in 5 minutes. Oh, yeah. As well. Now, yeah, yeah, it's very sensitive. Yeah, so when you code the net logo, the order of the code is really important, right? So like in setup, you should put reset ticks last as a like last comment. You should not put the reset ticks in the first, right? Good. Does it work? Oh, nice. Okay. And okay, good. So now we're gonna make a plot to count that counts the branch trees. I mean branch vegetations, right? So let's make a two global variables, burn trees and initial trees. So burn trees and initial trees here. So we have two global variables to count the proportion of the burn trees to the initial trees. Okay? I mean over time. Okay, good. And then let's make a one command here. So we're gonna set initial trees variable to count patches that is that the peak color equals green. So if the patches, if the initial tree, it's just like a count the initial green color patches, right? So you can just copy it, and then you need to put this in the setup function, right? So, but after you maybe here, yeah. So this code should be after the code that you define, where you define the vegetation with density, and then you should put this, right? Yeah. So let's just this code be the after everything before resettings. Okay. Yeah. Between the code and then resettings, you can just put it here, right? And then you need to set the burn trees to 0 first, as you know, in the first code here, after CA. So between the CA, which is clear all, and then you set the burn trees to 0, and then as patches. So just make sure you have this structure here, right? The order. Okay. So now we initialized burn trees and also initial trees. So now we need to count how many burn trees over time, right? So add this following the code to the ignite procedure here to add burn trees. Add 1 to burn trees. Every time the trees are burned, right? So let's go to ignite function and put this code here. So after the burning is true, then you can just put. I mean, you can put this anywhere actually, but I just put it here. Okay. Right. So whenever the trees are burned, the one patch this changes state burned, then we're gonna add 1 to the burned trees. Okay. So okay, and then we need to report it, right? So I think we used before in lab 3, right? The report function. So we can just make a new function. I'm gonna put the last. So here we're gonna make a report function named %burnt and report, which is the same as the return, right? So you can just put the burn trees divided by initial trees multiply 100. It means that proportion of the burn trees to the initial tree, right? So we can call this, return variable with just calling this name, the %burnt in the interface, right? You can just copy this %burnt and then make a plot here. Oops, yeah. Make a plot or monitor, yeah. But plot looks better, so I'm gonna make a plot here. And the name, maybe just %burnt. And then X label will be ticks or second or hours. And then the Y variable will be the percentage. And then here we can just plot %burnt, right? So we just put like this way. Is it too small? Okay. Yeah, you can just see the HTML file. You can, yeah. And then please check if the plot works well. You can resize it. Actually, you can just make it big like this, right? So yeah, you can see how many trees are actually burned over time. Oh. I only have one more step. So if you have a question, just let me know. I'm gonna go to the next step in three minutes. This is the unit class. Oh. Yeah, that was so. Yeah. Okay, good. So and then for the next step, we're gonna put this new function, which is which is a wind speed. Okay. Yeah. So we're gonna make a 4 global variables that represents the probabilities, the directions of fires. So there's north, west, south, east, right? So let's make a. So I think you can make a 4 slider. Okay. So I'd rather to make a 4 slider. So let's go to the net logo, and then let's make it a little bit like a neat. So let's make a note, and then you can put maybe I'm gonna put the direction, or you can put the wind speed or something, wind direction or something. So and then just click OK. I'm gonna put it here, and then put slider named ignition N first, and it will be 0 to 1 with the step of 0.05. And the initial value maybe 0.75 is your, you can just decide. Right? And then just let's make a 4. Ignition N, ignition west, ignition east, and ignition south, right? So I'm gonna make ignition west. Here. And then ignition east. So like this way. Yeah. So we make a 4 directions. So now we can adjust the speed. So wind direction. So if the ignition N is really larger than others, then the fire spread to the Okay, good. So let's go back to code, and then we need to make a code to neutralize this function. So let's see. So now we have a new functions to choose one of the neighbor, right? So now we when we choose one of the neighbor, we can just choose like this way, right? With just neighbors 4 or just neighbors, right? It means that just one of the neighbors. But if you use the bracket like this way, after add points like this way, it means that we can choose one specific neighbor out of 8 neighbors. Okay, so here, I'm going to explain later, but we need to put this first. Okay, so here, start by deleting the existing code from the Go procedure, right? So we can just delete. Okay. Delete this. I mean, I just make it to hit comment like this. We'll just delete it. Just delete everything inside of inside the ask patches with pickle array. Right? Like this. Okay, good. And then we're gonna make functions to catch fire. I mean, for making the wind direction function. So let's go back here and just copy those code, then I just paste it inside the ask patches function to make a code that function says the spreading fire to the north. So here we have at points. So it means we're gonna choose one neighbor at here. So let's see. So here we have a left side. We have a number on the left side and a number on the right side. So I'm gonna. So we can put -1 or 1 for both sides. If it's -1, it means west. If it's 1, then it means the east. Oops. And then on the right side, if it's -1, then it means the south. And if it's 1, then it's north. So now we have a 0, 1 right here. Right? It means that from this patch, we choose the patches, the north patch, right? The patches to the north of this patch. So because it's a 0, it means that there's no direction west or east, but we choose 1, which means the neighbors to the north. So if it is a 1, 0, then it means that the neighbors to the east. So we chose the neighbors that's located to the north. And then if that patch is green, then we're going to ignite that patch with the certain probability that is dependent on the ignition end. So if the ignition is like a bigger, then high likely to get on fire, catch on fire, and fire spread to the direction. Right? So now we need to make other like 3 directions, right? North, south, because we already made the north direction, so we need to make west and east and south too, right? So let's just copy here. And then paste after this, and then ignition of maybe south, okay? And then you need to change this to the -1. That's all. Okay. Yeah. And west patch, there should be -1, 0. Yes. Sorry? Oh, yes, we need to. Sorry. So yeah, of course, yeah. And then we need to change the ignition end to south. Yeah, if it is south, then west, and east like this. Yeah. So we have all four variables, and then by adjusting those four variables, which are each and W, south and east, then the fire spread in different direction. Right. Good. So you're done with this, then just go back to interface and just those one of the variables and check the fire spread to the certain direction. Let me check mine. Oh, let's see. Yes. Weird. Oh, yeah. So if you set the initial n to like a larger number than others, then the fire spread to the like north, right? Good. Okay, so is there any question? Oh, you if everything is fine, then you're now yeah, you can do exercise. Yeah. Weird. Yeah, it's all okay. Yeah, so yeah. I see. Oh, yeah, you can. Okay, so I think it's all for today. So if you have a question, just feel free to let me know. I'm gonna be here until the class time end. Okay. Thank you.
Can you get back to the to-go function?
Yeah.
I think it's real awful.
This one.
Yeah.
So I'm gonna stop sharing. I mean, stop recording and sharing. Oh, seems like I didn't record the video for today. Ah, should I do this again? Okay. Oh, it's recording. Okay. Oh, it's recording.